Good morning. Good morning, everyone. Once again, the next topic for today is efficiency of solar photovoltaic energy conversion, which is under our technological advances. And this is going to be enhanced and properly explained to us by Dr. Engineer SALLEM, who is an associate professor of electrical systems at the University of Sfax, Tunisia, and a member of the LSEER Labaratory, where she leads the supervision and diagnosis of renewable energy systems research team. She earned her Doctor of Engineering in 2011 and habilitation, which is HDR, in 2017. Her research focuses on renewable energy systems, including wind, photovoltaic systems, control strategies, diagnostics, and energy management. Dr. Salem has authored over 40 publications, contributed to the international conferences, and serves as advisor for the IEEE Power and Energy Society student branch at ENIS, supporting student development and fostering IEEE community engagement. Yeah, so Dr. Salem, the floor is yours.
Thank you for your introducing. I want to thank Mr. Olema for the invitation to this conference, which name is Inclusive Energy Futures, Pouring Innovation, Education, and the Green Economy. My presentation is entitled Efficiency of Solar Photovoltaic Energy Conversion, Technological Advances. So I will start by the outline of the presentation is focusing on photovoltaic solar energy in numbers in the first place. After that, I will present a summary of operating principle of a PV installation, and I will finish by solutions for improving photovoltaic energy efficiency. I will start my presentation by this figure, which is very relevant because we know that the Sustainable Development Goals, or SDGs, are a collection of 17 goals that must be reached by 2030. Especially, I will make the accent into sustainable cities and communities, afforded and clean energy, and the climate action. In this context, we can see that there is a strategy in the whole of the world to promote renewable energy systems. And the transition, energy transition, we have also many objectives to attain, like less than 40% greenhouse gas emission by 2030, less than 30% fossil fuel consumption by 2030, increase the share of renewable energy to 32% of final energy consumption and to 40% of electricity production. For example, in Tunisia, we have only 6% of renewable energy integration until now, and we hope that this percentage will be increased for the 5 next years. Also, we have to reduce final energy consumption by 50% by 2050. Here we talk about energy efficiency. And of course, less than 50% of waste sand to landfill by 2025. In this context, we can see the promotion of many renewable energy systems. In my opinion, in Africa, we can talk about especially 3 renewable energy systems, such as solar energy, wind energy, and the biomass energy. Today, I'm focusing on solar energy. which is really very promoted energy, especially in Africa and in Tunisia. So let me introduce what is solar energy. So solar energy can convert solar into thermal energy used for heating, cooking, or solar concentrator, or it can be converted into electricity. In this way, we are talking about photovoltaic energy, deduced for transportation, autonomous devices, electricity production, or for satellites. For satellites, it was the first use of the PV energy in the world. So here some images to show the diversity of PV applications. In numbers, the photovoltaic market reached in 2023 a production of 277 gigawatts, with a leader in the world for the China with 43%, as you see here, 43% for the China market. Of course, in Africa, I can see this 3% only. We hope that this percentage increase in the next years. Sorry. So this can highlight the major role of photovoltaics in the energy transition. As we can see in this figure, the production is increased until, I think, more than 75% of all new renewable electricity technology in 2023, which is a high number of photovoltaic installation in the whole of world. This is due to its continuous cost reduction, its technological performances, its accessibility, and the authorization procedure generally faster than those for wind or hydropower. Especially in Tunisia, the state encourages the installation of PV energy, for example, and there are many mechanisms to encourage installators or investors to build PV generation systems. So the increase in produced and installed volumes is accompanied by competitivity, workforce skills, investor confidence. This energy becomes a safe and mature technological investment. For example, in 2023, photovoltaic solar energy generated just under 60% of the total renewable electricity production, according to IRENA and estimations for 2023. So let's talk now about the principle of photovoltaic system. Every photovoltaic system is composed of PV panels, which can be connected in series or in parallel. After that, we have the inverter or the microinverter. The role of the inverter is to extract the MPPT from the PV and to convert DC current to AC current. Of course, we can see many types of PV installations. It can be for dedicated for residential sector. In this case, the PV is installed especially on rooftops of the residential sectors. Every installation is equipped by DC coffre, convert an inverter, of course, DC AC, and the production is converted or is injected totally in the grid. Another type is the industrial sector. This gives to the installer to buy or to buy the extra energy for the grid, and the PV power plant. So this type of installation This type of installation is dedicated especially for investors who want to build PV power plant and to buy the energy to the. For example, in Tunisia, we have only the Society of Electricity and Gas. Donc, it's the, I don't know in Africa, maybe after you can tell me how in Africa, if there are investors, how they can buy the energy to the state. Another type of installation, which is many relevant, it's PV pumping. So this type can resolve problems, especially for irrigation. Every installation or every PV installation must be equipped with these components, which are the PV, the DC-DC converter to extract the MPPT from the PV, the DC-AC inverter. Of course, the principle consists on injecting the load after the connection between the inverter and the grid, when there is the same frequency, the same voltage, and the same concordance of phases. We can inject active power, and we can inject or absorb reactive power according to grid needs. Here we can talk about MPPT techniques. MPPT means maximum power point tracking. We can find in the literature the perturb and observe techniques, hill climbing, and conduct incremental. There are also many non-conventional methods like fuzzy logic based methods, neuronal based methods, etc. I don't know if you know about the equivalent schema of the PV model, but it's a PN junction, which is sensitive to irradiance, and every PV cell can generate current and voltage according to this figure. Of course, the association of the PV in series induce the voltage incrementation, but the parallel connection increment the current. Here we can remark that the enemy of the PV systems is the temperature. Because when we see this figure, we can remark that the elevation of the temperature reduce the efficiency of the PV systems. Contrary to irradiance, we can see that the incrementation of irradiance increase the current generated by the PV, and thus the power of the PV can be incremented. The inverters can be subdivided into three types. We can talk about central inverters, multi-string inverters, and the micro inverters. It's a revolution in the PV system generators, because it can offer to consumers to have his proper installation. We need only the PVs and the microinverter to generate directly the EC current, which can be injected into the grid, or we can supply the equipments in the residential sector. This is a figure to explain the principle of PV inverters, and which are composed of DC-DC converters, DC-AC inverters. And here this figure highlights the sensors, the data acquisition board, the data transfer and treatment, this why is to detect faults and classify these faults. So if we need a monitoring system, we have to add to the PV system this board to can monitoring our production. So the of this presentation is about solutions for improving the efficiency of photovoltaic energy. Every PV system is especially composed of a PV panel, the inverter, and it can be also associated with energy storage system. So if you want to improve the efficiency of photovoltaic energy, we have to improve the efficiency of PV panels, the efficiency of PV inverters, and the efficiency of energy storage systems. For example, this figure shows the architectural integration of PV installations into buildings. I want to highlight this figure because the revolution in the PV systems consists of integration of PV installation into buildings, because we can improve efficiency when we place the PV, of course, in the good orientation and inclination. Here we can remark that the PVs can be integrated in the rooftop, in the balcony, in the curtain wall type, or sunshade or wall, and this can increase the integration of PV, especially in buildings. So the first reason, or the first solution to increase the performance of the PV installation is to choose a high efficiency solar cell. So here we can see there are many contributions and many inventions in the cell photovoltaic types. The market, or the international market, is especially distinguished by three types of technology, of PV technologies. The first is the monocrystalline PV panels, the second is the polycrystalline PV panel, and the third one is the thin film PV panels, which is which can concurrate the monocrystalline, because it has an efficiency which can reach 23%, such the monocrystalline PV panels. So here there are some new configuration and some new technologies which highlight the interest of the thin films that I talked about now. We can see the solar photovoltaic system in tiles. So these are photovoltaics, and many also solutions consists of replace the classical photovoltaic system by stylites of roof windows, transparent or semi-transparent, and even colored PV systems. Also, now in the industrial sector, we can find bifacial PV systems to improve the efficiency until 30%. So the principle is shown by this figure. We can also so this is called half cell cut cells. It can improve the efficiency of the PV system, because the cell is divided into two cells to increment the efficiency, especially when there is a shading. Also, we can see there is a tandem cell track record, which can improve the energy efficiency or the efficiency of the PV cell until 29.8%. Its revolution in the PV systems. So here we can we can see by this figure the revolution of the PV systems until 125 for cell in 2002. It can reach now 210 bifacial, and the revolution is very quick. I can say in PV systems the revolution is really very quick in the whole world of world. Another axe to increase the efficiency of the PV systems is to optimize the environmental conditions. So generally, we have to choose a tilt and the orientation for an optimized tilt and orientation. For example, in Tunisia, the majority of PV installations are oriented to the west with an inclination of 30 degrees. Here there is a figure showing the impact of temperature elevation on the efficiency of the PVs and the impact of irradiance of in terms of power injected from the PV. So we need to place PV systems in a zone when it's better to not be far from this temperature. What else? Donc, it can decrease in efficiency. The third method to ameliorate the efficiency of PV systems is to verify the electric connection, is to ensure that all wiring is intact and properly connected to prevent energy losses. Also, second method is a visual inspection. It's a very powerful method. We can see if there is a problem by the visual inspection. We can detect cracks or damage that could compromise the integrity of the module. And generally, we have to maintenance. We have to do the preventive maintenance to replace defective components, lighting fasteners, checking simulation and wiring, etc. Also, there are many optimization algorithms for MPPT to ameliorate the PV performance, because the shading can lead to problems and can lead to decrease the efficiency of PV. So here there are many methods which are developed in the literature. We have many works, for example, which are published improving the MPPT algorithms. This figure shows the impact of shading into the MPPT. So we can see here that when there is a shading, we can find many MPPT points which can decrease the performance or the efficiency of the PV inverter. So the optimization consists of recording the first peak found and then searching for the next one. A comparison made between two peaks to decide whether to return to the first, stay at the second, or continue the search. So here, for example, in this figure, the maximum power is given for this point. So we have to choose this MPP when the PV system is shaded. The fourth method to ameliorate the performance of PV systems is the periodic cleaning. Here we can remark that there is an industry in the whole of world which can remove the dirt and debris that obstruct the solar cells. We talk about remote controlled robots. Of course, their operation prevents walking on the rooftop. And sometimes we don't need water to clean these PVs. So it's a very good solution to improve the efficiency of the PVs. So here there is an industry in the world to prevent and to clean periodically the PV systems. Of course, another solution already Mr. Amer talked about monitoring and the SCADA systems is to monitor the data analysis to optimize photovoltaic solar energy production. Here, so we can see a monitoring system for PV installation, which can introduce the production and prevent the users from problems which can be, of course, which can attack the PV system. So here also another monitoring system. And for example, this is an intelligent EV curve scanning to improve on the efficiency of the PV systems, which was developed by a China industry. There is also other methods like IoT-based platform monitoring. So here we can use IoT to monitor PV systems. We need, of course, the database to decide, of course, if there is a default in the MPPT stage, in the battery, in the inverter, or in the electrical network. I will introduce now a new diagnostic of PV systems. But diagnostic is already a known name for food sector, for medical sector, for energy sector, and for environmental sector. The diagnostic is the identification of the probable cause of a failure using logical reasoning based on a set of information obtained from an inspection, a check, or a test. So if we want to improve the efficiency of PV systems, we have to diagnose these installations. What is diagnostic is the fault detection and localization. And of course, the diagnostic can lead to or can help us to observe the symptoms of the failure and identify the cause of the failure using logical reasoning based on observations. There are many steps in the diagnostics. The first step is the data acquisition. That means that we need data collection. Generally, the data can be the current, the PV current, the voltage current. It can be the DC current generated by the DC converter. It can be the AC current generated by the PV inverter. The second step of the diagnosis is the detection. Detection, of course, consists of making a binary decision, either the system is operating correctly or a failure has occurred. The result of the detection process is an alarm indicating that the actual system operation no longer matches the healthy operation model. So here we can use IoT, we can use SCADA, or we can use the model to decide if there is a defect or not. Once we detect that there is a fault in the system, we have to localize the default. So the third step is the localization. which triggered by a detection procedure and consists of more precisely determining the faulty components. The fault can affect a sensor, actuator, a process, or a control unit. Of course, the fourth step is the identification. The identification involves estimating the magnetic and temporal evolution of the fault in order to best explain the system behavior. And once we identify the fault, we can decide, it's the fifth step, we can decide either we can stop the system and isolate it of course, to pass to the maintenance, or we can accept the state and we can continue operation. So the decision making, once incorrect system operation is detected, it's crucial to act in order to maintain desired performance or limit degradation of the real system. Decision makers also choosing among several options, such as stopping the system for maintenance or accepting degraded operation. What are faults affecting PV installation? It can be lightning. It can be due to fire. It can be due to shading. It can be due to arc fault or micro crack. So also it can be in the PV system, like problem and default in bypass diode or blocking diode, which can be also affected by faults. So here we can talk about approach of diagnostic. Generally, we have precisely two concepts or two diagnostic approach: the model-free methods and the model-based methods. The difference between the two methods is the cost, the online or the offline methods, and the types of faults that can be detected from these methods. For these methods, for example, we can also talk about two types, essentially, that are electric methods and non-electric methods. If I start by non-electric methods, here we can distinguish visual and thermal methods, infrared thermal imaging, visual inspection, or electroluminescence imaging. So these methods are if I return to this page, they are model-free methods and they are non-electrical methods generally, because they are based on equipments and can detect hotspot, soldering defect, shading, wiring issues, overheated junction box, and cracked model. The advantage of these methods that they are online methods. What means of online methods? That means that we can diagnose the PV system while it's operating and while it's connected to the grid. So they are online methods, but the problem that these methods are extremely of course, extremely expensive, and they are not make it. They are periodic. Voilà. They can be periodic methods, because it can be, for example, visual and thermal methods or visual inspection can be one monthly or annually. So this is the problem, and especially it's the cost, which is very expensive for these methods. The second method is the electric methods, which can be also based on model or non-model. So here we can distinguish the famous methods based on IV characteristic analysis or power losses analysis. And another methods consists or electrochemical impedance spectroscopy methods. These methods can detect grounding faults, short circuit faults, faulty connections, partial shading, and module degradation. So the EV characteristic analysis uses the EV characteristic to detect faults by comparing the estimated IV curve with the measured IV curve under a given irradiance. Here we need the model of the IV characteristic to decide if there is a fault or not and to classify the fault. The second method is the electrochemical impedance spectroscopy. I don't know if you have an idea about these methods, but it's a famous method, especially in the battery diagnostic surfaces and many other systems, either the medicine sector. The principle is to inject a variable frequency signal to the system in order to generate the frequency response of the internal impedance. This method can be applied to PV system to diagnose the health of this PV. So here we can see there are many equipments that call it spectrometers, which can be used to extract frequency response of the impedance, but these equipments are very expensive. So I will show you after a method that we developed in the laboratory to use this method, but it was a very cost-effective method. So here I will give you an example that we developed also in laboratory. It's a diagnostic method based on EV characteristic. So it was model-based. It was an online method and it was an electrical method. This method is based on estimation of internal parameters. So the prototype was developed in our laboratory, which in the National School of Energy of Sfax. The laboratory is LSEER, it's the Electric System and Renewable Energy Laboratory. So here we have 3 panels which were connected in parallel. We have a data acquisition board, a data treatment board, and a laptop here to monitor the EV characteristic. So here the method has many steps. Of course, we have to expose the PV in the optimized inclination and orientation. We measure the temperature and irradiance based on solarimeter and thermometer. We have calibrate the voltage current sensor and their programming. After that, we vary the DC-DC converter to have MPPT voltage, and we acquire the extracted EV curve portion, because here when we extract MPPT, we can't reach the short current circuit the short circuit current. So we have to estimate the short circuit current according to an algorithm that we developed, and we can use this curve to detect faults in the PV panel based on series and shunt resistance estimation. Here I can tell you that the shunt resistance is very sensitive to faults that can be affect the PV panel. The second prototype was also developed in our laboratory, and it consists on using the electrochemical impedance spectroscopy, but the method it was very cost effective because we just inject the variable frequency in the DC-DC converter, and we can find, according to current and voltage acquisition, we can deduce the frequency response of the PV impedance, which inform us about the shading problem. In our case, we studied only the shading fault, and this method can detect the shading by the variation of the spectrum or the frequency spectrum of the impedance. So I thank you for your attention. I'm ready for your questions. I hope this presentation was effective and was relevant for you. Thank you, Prof. Olema.
Wow. Thank you very much, Dr. Engineer Souhir SALLEM, for the presentation. I'm just fascinated, and there are a lot of things that I didn't know, especially cleaning. I do installation of solar panels, but the methods that you have shared are so nice. And even with my team here, we are trying to see how best we can also adopt some of those methods to clean our solar panels that we have already in use. So I did just I really like to thank you and probably to come and especially you and also your team to come and to attend here right here. I've been to Tunisia about 4 times already.
Okay.
Tunis. So yeah, so I have quite a number of colleagues, also ITRUP members. So next time when I travel now, I know I have to meet you, Dr. Engineer SALLEM.
Okay.
Yes. Now,
there is
I did
an
just,
event.
let me ask.
There is an event which called TSYP. If you will come to Tunisia, it will be held in December this year.
Yes.
It's an IEEE event.
No, this is now too near. It is too soon. Maybe next year. Next year, of course. I know the
Okay.
ITP Tunisia.
I'm this year I'm
Yeah.
a member of a jury in the TSYP event, which called the Eurothopia Challenge. So the Eurothopia Challenge is called for students to find a solution which respect the objectives of sustainable development. So I am a jury member of this challenge. Unfortunately, you can't come this year, so it will be the next year. You are welcome in Tunisia, of course.
Maybe probably you send the invitation and then we will see what we can do later. And now this competition, is it all local for Tunisians? Because we have students here in person and also online. And probably some of them may be interested to share their ideas and compete. I don't know. You'll advise that one. And then also, I'd like to ask somebody who has a question or a comment to show up as we almost conclude for Dr. Souhir's presentation. Thank you.
Thank you.
So we have a we have a question.
Hello?
Yeah.
Yes. This is Sam from IEEE Isbat University student branch, and thank you so much for your presentation. I would like to ask about the effects that can be on a human body for living for a very long period of time closer to a photovoltaic grid? What can be the effects on their skin, maybe, I don't know, health, or if there are any other negative effects on human body for living for a very long period of time closer to a photovoltaic grid?
Right, thank you for your question. Actually, I didn't hear about negative effects of PV systems on the body, on the human bodies, because there is no radiation, or there is no infrarouge radiation which is emission. Contrary, the PV systems can reduce the infrarouge radiation because they absorb irradiance. So, in this reason, they can ameliorate the climate, and they can avoid the gaz, on dit le gaz à effet de serre en français, donc maybe.
Yeah,
so
no, I speak French.
it can be useful. It can be useful for humans. That's what I know. I don't know. I don't know if there is a negative impact. Really, no. There is no research that indicates that.
Okay, thank you so much.
Yes, thank you, Doctor. Good morning. So my name is Tony. I have two questions. The first question is not very technical. It's about, I wanted to understand the major challenges you have faced while implementing such a projects in Tunisia. That is one.
Excuse me, can you repeat
the second
the question?
one is about which I wanted to understand the major challenges you have faced while implementing such a projects in Tunisia. Am I clear now?
Professor Olema, can you write the question, please? I didn't hear the question.
Yes, I'm saying.
He's asking for the challenges that you face implementing your research. Yes.
In Tunisia.
Yes.
Yeah, the second one is about, I wanted to understand if the installations of solar panels has the intensity or the even distribution of solar energy. Is it clear?
No.
What was the question?
Because sometimes I cannot hear.
One place to another has its impact on the distribution of equal distribution of solar energy.
Yes. Is he asking? Maybe what I'm going to do is I'll ask him to write, and then we share it with you directly so that he can read in writing later, probably. Is that okay?
No, I didn't. I didn't
Hello?
understand. Hi.
No,
the second question. The second question is.
Doctor, what we're saying, I'm trying to now suggest. His question is going to, yes, the question is let him come, and it is about.
I just wanted to understand, for example, the installation of more solar energies in Tunisia, if it has any effect about the even distribution of solar energy, for example, in Uganda. If you install more solar panels in Tunisia, does it affect the solar energy we get in Uganda or not?
Yes. No, his question is that if you install solar panels or power in Tunisia, does it also affect? That's the question. solar panels is giving us the power. But I think that question is the solar
installation into Uganda.
Yes, that question. Probably what we can do is direct it.
That is it. Yes.
You maybe come and explain.
You can write your question in the chat.
Okay, I can ask you. Let me try to ask it again.
Mm-hmm.
Does the solar installation in Tunisia
Mm-hmm.
has an effect, solar effect intensity on
Right.
our installation in Uganda?
What?
Is it clear?
Have
you got the question?
No, I don't. I have no idea about this. The solar installation.
No.
He has no installation.
So now what we're going to do is we're going to write that question and I'll send it on your WhatsApp later. Then you can answer.
Good. But I will respond to the first question.
Okay, otherwise, thank you.
Okay, about challenges in Tunisia. Yes, we have many challenges in Tunisia to promote and to install PV systems because that actually Tunisia in 97% is based on gas-based production for electricity. But there are many encouragements from the state, and there are now many investors which can and which have the priority to install PV power plants. For example, the last week it was a power plant with 55 megawatt. And now in Kerwan, we start the installation of PV power plant with 100 megawatt. This can increase the PV penetration in Tunisia. But maybe there is a problem in the high PV and penetration in the grid is the voltage instability and frequency. This problem, it's not now in Tunisia, it's not until now observed when because we have only 6% of renewable energy integration in the grid. But maybe in the 10 next years, we have to resolve problems in relation with, especially with harmonics, with voltage stability, voltage sags, and frequency, maybe frequency, because I see many papers, many research papers that talks about frequency perturbation in the grid, in the PV integration, in the high PV penetration in the grid. But in Tunisia, until now, we haven't this problem. Maybe there is a slide that I didn't let it in this presentation, but in Tunisia we have a promotion and we have an evolution in the PV installators market, such as installators studying of this energy. Also, we have markets to buy the PVs. Of course, it's from China. We haven't really industry to create PV panels. I will see if I receive from Professor Olema.
Yes. Yes.
Did you send me
So you are done?
the question?
Thank you, doctor.
The second question?
Your network is breaking. I think your network is breaking. So your voice is breaking.
Yes, yes, yes.
So are you done with the questions are done, and the other questions I write it and send to you on your. Thank you for your presentation. As I mentioned earlier, we will always yes, you are now clear as of now. So what we are saying is that we thank you for the presentation, and we will continue to invite you for our events, present, and we have so many student activities
You are welcome.
and so on. So we will always once a while invite you to make a presentation. We love your presentation. It's informative, real good presentation with good.
Oh, thank you. Thank you very much. Thank you.
Uh,
Maybe sometimes my English is not very well
like once
because
more.
I lose the words. You know, in Tunisia, we are French based, even in school, in university. So the majority of studying is with the French. Okay, so maybe for this reason, sometimes I lose words in English.
Yeah, it's okay. Yeah, even in present, your English is good. No one
Okay, thank you. Thank you.
is doubt is okay. Now you will ask the audience, they are asking for your presentation. You will share with me, and then I will share later after this event.
Yeah, of course. Yeah, okay. I will send you the presentation, and you can share it with your students.
Okay, the participants this time. Okay, thank you very much once more. The next presenter is Dr. Luanga Chintu Fred, CEO of ICT. Dr. Luanga, are you online now? You can start presenting. His topic is the role and the professor, upcoming professor. So, and that's why he took this topic. So, sir, I've seen you are you are sharing your presentation. Please. The sharing is taking time. I don't know. Can you start it again, all over again? Thank you. Yes, Luanga, please, you are online now. We can see your presentation. Put it on presentation mode and then you start your presentation. Doctor, we can't hear you. We can't hear you.
Doctor, we cannot hear you.
Is it audible?
We can now hear you. We can now hear you. You can now proceed and place it in your presentation mode. Yeah.
Dr. Souhir, can you stop slide sharing?
I already stopped the share screen.
Okay. Thank you.
Okay.